Hi guys, welcome to Momentum with Vedantu. Welcome to another live session. We are going to revise 5 questions from JEE Advanced syllabus of SHM. Um, SHM is a hard topic and it's a very important topic. The questions come. Questions from this topic can be mixed from various different topics. It can be mixed with electrostatics. It can be mixed with other chapters as well. Okay, so you have to. It's good that you know basics of SHM. Okay, so let's do some questions. Let's do some questions and let's see how we are able to do. How you are able to do. Okay, so by the way, this is Momentum with Vedantu. I'm your master teacher, Aaditya Pandya. If you're here for the first time on this channel, please like, share, and subscribe to our channel and hit that bell icon for notifications. Okay, so let's start. Let's start, guys. Let's start. I'm excited. I like this topic. I really like this topic. It's got very hard questions, which I don't like in general, but like it's exhilarating when you're able to solve them. Okay, also guys, if you haven't joined our Telegram group, I suggest you join our Telegram group. I'm going to add notes on there. All the questions and the solutions after the class will be added there. Okay, my chat is not getting refreshed, just like always. It's not getting refreshed for some reason. Why that happens, I don't understand. Okay, just give me 1 second. Give me 1 second. 1 second. Oh my god. Hi, Surinder Singh is always here. Hi, Surinder Singh. Movie Buff is here. Anonymous is here. Wow. Oh, Neeraj is here. Oh, hi, Neeraj. And Neeraj, I think you pinged me on Telegram as well, right? Yeah, correct. Okay, okay. Yeah. अरे movie buff, I'll get to that. Okay. Thermodynamics का समय है. Neetu, thermodynamics will be 4 to 5. Okay, thermodynamics will be 4 to 5. 4 to 5, 4 to 5. Okay, we are changing the timetable because many of you complained that 2 to 3 is a slot where you don't want your regular lectures to be. So thermodynamics is going to happen from 4 to 5. Okay, all the 2021 and 2022 lectures will start from 4 to 5. Happen from 4 to 5. Okay, guys. So let's look at the first question today. Let's look at the first question. Hi, astronomer me. Okay, hi, anonymous. Okay. Movie buff, Marvel based lectures चालू होंगे यार थोड़े टाइम में. Marvel based lectures में बहुत टाइम लगता है यार. अभी पहले पढ़ाई का lectures करते हैं, फिर Marvel based lectures में करेंगे. पक्का. I want you to पक्का. Okay, so let's talk about this. 3 simple harmonic motions. Okay. Shuyesh Prabhu Desai is asking, sir, Wonder Vision के trailer दिखा क्या? Shuyesh Prabhu Desai, yes, I saw it and I really loved that trailer by the way, but I have no idea what is happening in that. Okay. And people who are reading the comic books, they have told me that it is from Marvel's West Coast Avengers. So you go and check it out. But yeah, super trailer. I'm so excited to see what is going to happen. Okay. Anyways, guys, let's get back to this topic. Okay, superb trailer it was, but let's get back to SHM right now. Okay, awesome. So there are 3 simple harmonic motions in the same direction, having the same amplitude A and this same time period, and they are superposed. If each differs in phase from the next by 45 degrees, then you have to tell me which of the following statements are true or false. Okay, so now guys, in order to do such a question, let's just take 3 SHMs which are differing from each other in 45 degrees of phase. Okay, so let's just take x1 as A sine omega t. Then x2 will become what? Then x2 will become, first of all, it's not A sine omega t, I'm sorry, it's small a sine omega t. Okay, small a sine omega t. If you could chat me, बोलेगा sir, amplitude is not A, it's a small a. पहले मैं कर लेता हूँ. Plus 45 degrees. Okay, and x3 can be written as A sine omega t plus 90 degrees. Okay, so these are the 3 SHMs and these are going to be superposed. Okay, superposed, these are in the same direction and they are going to be superposed. Okay, what that means is that the net x will be nothing but the net displacement will be nothing but sum of these 3 displacements. Okay, this will just be A sine omega t plus A sine omega t plus 45 plus A sine omega t plus 90. Okay, plus A sine omega t plus 90. Now how to solve this, guys? So in this case, what we'll do is that we will add x1 and x3 first. We will add x1 and x3 first, and then whatever we get, we will add that to x2. Okay, so let's add x1 and x3 first. If I add x1 and x3, guys, if I add x1 and x3, you can see, first of all, this x will become a sine omega t plus, I don't know if you guys know, sine omega t plus 90 is just a cos omega t plus a sine omega t plus 45. Okay, now what will be a sine omega t plus a cos omega t, guys? This can be written as under root 2 into a sine omega t into 1 by root 2 plus a cos omega t into 1 by root 2 plus a sine omega t plus 45. Okay, why am I doing this? Why am I doing this? Because if I do this, guys, because if I do this, I can write the first and the second term as, if I do this, I can write this x as under root 2 into a sine omega t cos 45 plus a cos omega t sine 45. Okay, plus a sine omega t plus 45 degrees. Now, if you see, this can just be written as under root 2 into a into sine omega t plus 45 degrees, because sine omega t plus 45 is sine a cos b plus cos a sine b plus a into sine omega t plus 45. This just gives me a very beautiful final expression, guys. A very beautiful and clean and simple final expression. Hi Jishnu, hi everybody. This gives me very beautiful final expression. What does it give me? It gives me x is equal to root 2 plus 1 into a into sine omega t plus 45 into sine omega t plus 45 degrees. Okay, if you see this, this is overall just a single SHM with initial phase of 45 degrees. With initial phase of 45 degrees. Now you can click, you can take all the options you want. Hi Raja Surya, hi Raja Surya. Okay, so if you see, the resultant amplitude is going to be under 1 plus root 2 into a. The resultant phase is not ahead of the first by 90 degrees. It is actually ahead of the first by 45 degrees. Okay. Next, the energy associated with the resulting motion is 3 plus 2 root 2 times the energy associated with any single motion. What? What? Okay, so what to solve this? How to solve this? You have to understand what is the formula for total energy. I don't know if you guys know what is the formula for total energy. Okay, the formula for total energy is equal to, total energy is equal to half m omega square a square, which in this case, the individual ones, for the uh, individual SHMs, the total energy will be equal to what? The total energy will be equal to half into m into omega square into a square, because for the individual SHMs the amplitude was a, and for the combined motion, the total energy will be equal to half m omega square into root 2 plus 1 the whole square into a square. Now, if you see this, this will just become, if you see that, that will just become root 2 plus 1 the whole square. I don't know if you guys know that, but that is just 3 plus 2 root 2. Okay, so if you see, the total energy is actually 3 plus 2 root 2 times the total energy associated with the single motion. And is the resulting motion simple harmonic or not? The resulting motion, guys, is simple harmonic. So this option is also wrong. The correct answer is A comma C. I hope you guys understood. The correct answer is A comma C. Okay, I hope everybody understood. Okay, Akash, the PDFs are shared on the Telegram group. Okay, Shiva Sami, what about the next video? Shiva Sami, the next video in the evening is thermodynamics. We are starting with thermodynamics today. Okay. Mm-mm. Now, guys, before starting the next question, let's talk for 2 minutes about Vedantu's JEE Advanced crash course. Okay, if you are preparing for JEE Advanced, this course is just for you. You should go and check it out. You have to go to vdnt.in/JEECEE. India's best faculty is there to help you crack your advanced, and the course price is just 1999 if you use my coupon code. Okay, so I would suggest go and check it out. Okay. Anyways, let's go to the next question. I have a metal rod of length L and mass M pivoted at one end. Okay, so I have a rod of length L and mass M, okay, which is pivoted at one end, and at the end I have connected a disc of mass M and radius R. A disc of mass M and radius R. Okay, now this disc is attached at its center to the free end of the rod. Now there are two ways in which I can attach this disc. Okay, there are two ways in which I can attach this disc. Okay, the first way, guys, is to attach when it is not free to rotate about its center. When it is not free to rotate about its center, and the second way where the disc is free to rotate about its center. Okay, there are two ways in which I can attach this disc. The one in which it's not free to rotate about the center, the second in which it is free to rotate about its center. You have to tell me which of the following cases are true in that case. You have to tell me which of the following cases are true in that case. Basically, they are comparing the restoring torque and the angular frequency. They are comparing the restoring torque and the angular frequency. Okay, so let's try to solve these questions, guys. Let's try to solve this question. How do we do it? How do we do it? So first of all, let me just copy the diagram from here to here. Okay, copy and paste. Okay, now if I am talking about case one, guys, if I'm talking about case one where the disk is not free to rotate, the disk is not free to rotate about its center. Okay, where the disk is not free to rotate about its center. What that means is that as the rod rotates, the disk will rotate with it. So basically what I mean is that if I mark 2 points A and B here and here, if I mark 2 points A and B here and here, after some time when the rod comes in this position, after some time when the rod comes in this position, okay, the point A would have moved with the rod come here, and point B would also have moved with the rod to come here. Okay, this is which case? This is case A. This is case A. Okay, and what exactly is case B? What exactly is case B? Well, guys, the case B is going to be a case in which case initially case B is where the disk is free to rotate about the center. So how will that look like? Initially, if there is a point A up here and B up here, down here, okay, I've made 2 point vertical points. Then as the what rotates, as the rod rotates, the disk will not rotate with it, guys. The rod will only rotate, the disk will not rotate. Here, the point A will still be at the top and point B will still be at the bottom. Okay, the disk will not rotate with it. If I had a point C here and a point D here, the point C and D will come here and here. If I had a point C and D here, point C and D will also come here and here. The entire disk will rotate. And in the second case, the disk doesn't rotate, it just remains stationary, doesn't rotate at all. Okay, now that is the difference between the two sessions. That is the difference between the two sessions. Okay, now how to solve this? So in this case, guys, you need to remember the let's talk about the restoring torque and the restoring angular frequency. Okay, so case A is very simple. Case A is very simple. You can very simply understand case A. In this case, I can just write torque tau is equal to I into alpha. Okay, torque tau is equal to I into alpha. Now, what will be the value of torque tau, guys, in this case? What will be the value of torque tau in this case? In this case, the torque will be provided by two different gravitational forces. One on the center of the disk and the second on the center of the rod. Okay, one on the center of the disk, second on the center of the rod. Okay, I hope everybody understood. So here the torque will be due to both those forces, whatever it is, we will calculate. And here, what will be the moment of inertia? Here the rod is rotating about this point, so its moment of inertia will be ml square by 3 plus the disk is also rotating about this point, plus the disk is also rotating about this point. So what will be its moment of inertia, guys? In that case, its moment of inertia will be calculated using parallel axis theorem. Its moment of inertia can be calculated using parallel axis theorem. I will write it as mr square by 2 plus ml square. Okay, using parallel axis theorem into alpha, into alpha, into alpha, alpha into this. Okay, I hope you guys understood. I hope everybody understood. This is the moment of inertia in the first case. In the second case, guys, once again, the torque will be produced by this force mg and by this force mg only. So torque will still be the same. Torque will still be the same. Now, in the second case, what is happening is that the disk is no longer rotating. The disk is just doing translatory motion. The disk is just doing translatory motion. If you see, the disk is just doing translatory motion from here to here. So what we do is, in such a case, we can consider this disk as a point mass. In such a case, what we can do is we can consider this disk as just a point mass, because it's not rotating. We don't need to worry about its size and radius and everything. I can just consider this disk as a point mass. It's not rotating, just translating. And okay, and in that case, what will be the value of I? In that case, the value of I will be ml square by 3 of the rod plus capital ml square of capital ml square of what? Capital ml square of the this thing. Hmm, capital ml square of अरे यार मैं भूल गया, of the point mass. Okay, I hope everybody understood. Really hope everybody understood. Am I buffering, guys? Am I buffering? If somebody is saying I'm buffering. Okay. Hi 2021 aspirant. Hi. Okay, I will start very soon 2021 and 2022 lectures. Full focus will be on those two lectures only, guys. Don't worry. The sessions of revision are very uh, they are going to end very soon. Don't worry. Okay. So now, guys, if you look at both the cases, the torque is going to be provided. The torque that is there will be provided by the same two forces. So the torque is the same in both the cases. The torque is the same. The torque is the same. Okay, and if you talk about the angular frequency, in the linear case, the angular frequency is under root k by m. Here, the angular frequency will change to under root k by I. Okay, under root k by I. So you have to remember that omega is inversely proportional to 1 by root I. You have more moment of inertia, you have less angular frequency. Now, in the case of A, the moment of inertia is bigger compared to the case B. In the case of A, the moment of inertia is bigger compared to the case B. I hope everybody can see that. therefore कहाँ गया इधर आ जाओ. Therefore, omega A will be less than omega B. Okay, omega A will be less than omega B, and the correct answer will be option A and D. Option A and D. STV, sir, can you do a quick revision session? Can you do some STV? Which revision session? Which revision session? Tell me which revision session you want. Okay, I hope everybody understood, guys. I really hope everybody understood. This was a khatana question, kind of, but not so much. Okay, you have to remember, if a body is not rotating and it's just translating, you can consider it as a point mass. Okay, you can consider it as a point mass, and you said situated at the center of mass of the body. Okay, and you can just do that answer. Okay, next is this question. Consider the spring mass system which is submerged in water as shown in figure. What will be the phase space diagram of one cycle of this system? Oh my god, what is a phase space diagram? So guys, if you look at this question, what exactly is a phase space diagram? Phase space diagram is nothing. Phase space diagram is nothing but a diagram between momentum and position. A diagram between momentum and position. Okay, so let me draw this diagram. Okay, chalo, theek hai. Like this is the phase space diagram. How will the phase space diagram look? Okay guys, how will the phase space diagram look? So first of all, you have to understand, for let's take a line as our reference line, and we will measure all the heights from this line, and let's take the upwards direction as positive. Okay, so that means if a body has velocity in the upwards direction, its velocity will be considered positive. If it has a velocity in downwards direction, its velocity will be considered as negative. Also, at the same time, if the body is here, its position will be considered positive, and if the body is down, its velocity will be considered negative. Okay, now if you see, all these bodies are starting from a positive position. All these bodies are starting from positive position. That basically means what? That basically means that I just picked up this body a little bit, shifted it up a little. Okay, I just shifted this body up a little from its equilibrium position and let it go. Now, in that case, if I shift it from equilibrium position and let it go, guys, what will happen to this body? Can you guys tell me what will happen to this body? What will happen to this body? In that case, that body will start moving down. In that case, in that body will start moving down. When it comes back to its mean position. I don't like this diagram. You know what? I'm going to make my own diagram. Okay, one second. I don't like their diagrams. It's just horrible. Horrible, horrible, horrible. Okay. Do it. I'm gonna make my own diagrams. Okay. Yeah. So when one second that body comes back to the reference line actually. Yeah. Ye raha. See, look at my diagram, okay, and how clear it will be. Or not. I don't know. Okay. So let's say this is my body and this is the liquid, and like this. And guys, I choose this as the reference line. Okay, the upwards direction is positive. What I have done is I have shifted this body in the upwards direction and then released it. So it will start going in which direction? It will start going in downwards direction. When it will come back to its mean position, it will have velocity in downwards direction. So when this body is starting, initially its position will be plus maximum, but when it comes back to its mean position like this or like this or like this or like this, its momentum should be negative. Its momentum should be negative, which rules out this graph and this graph. Both these graphs get ruled out. Both these graphs get ruled out because here, when the particle comes back to its original position, its momentum is positive, but when it comes back to its original position here, it should be negative. Okay, I hope everybody understood. Now, next is hi Nikhil Sharma. Next, what happens, guys? Next, what happens is that after it completes one cycle, it will not go back to its initial position. It will stop a little bit short of that. Why is that? Because of drag force. Because of drag force. Because of the drag force, it will start slowing down. It will be a damped oscillation. It will be a damped oscillation. So what happens is that after one cycle, its amplitude should become smaller, which means that the cycle should actually look something like this, because here if you see, after one cycle amplitude becomes smaller. So the correct answer for this, the correct answer for this will be option B. Hi STV. Okay STV, I will think about it. I will think about your suggestions. I will definitely think about your suggestions. Okay. All right, I hope everybody understood, guys. Really hope everybody understood. Okay, next is this question. Hi Ankit, how are you? How are you? Oh, this is a good question. And also, somebody was asking me this question on Telegram just today, and that is this that I have a fixed ring of radius 1 meter which has a positive charge distributed uniformly over it, and the particle of mass 0.9 gram and charge this much is placed on the axis at a distance 1 centimeter from the center of the ring, so that the motion of this particle will be simple harmonic. Calculate the time period of oscillations. Okay, so if you try to solve this question, guys, what is given to us? I have basically a big ring, okay, with some charge q1 distributed over it, where q1 is given by this value, okay, and also at the same time this is a positive charge, okay, this is a positive charge. I have to make positive charges like this, okay, chalo, theek hai. So demanding. Okay, next I am placing a charge on the axis of this ring. Okay, at what distance am I placing it? I'm placing it at this distance, where the radius of this ring is given by this value 1. Okay, and I am placing a negative charge here, minus q2. Okay, what is this minus q2? This minus q2 is going to be this. Now there will be a force on this charge. There will be a force on this charge. How much force will be there on this charge? Let's try to calculate that. Okay, let me remove this for 1 minute. Okay, let's try to calculate the force on this charge. Okay, what will be the force? I can write force is equal to charge into electric field. In this case, the electric field will be equal to kq1 x upon r square plus x square raised to the power 3 by 2. This formula you should have remembered. This will be the formula. Okay, guys. Now, here, if you see, in this case something is given to us. Okay, what is given to us? It's given to us that the distance x is 1 centimeter and the distance r is 1 meter. That means what I can say is x is much smaller than r, and what I can just write is that x square plus r square is approximately just equal to r square. Okay, I can substitute this into our force equation, and when I do that, the value of F will just change to this. The value of F will just change to this, Q. Okay, x square plus r square raised to power 3 by 2 will become just r cube. I hope everybody understood. Now, because of this force, guys, because of this force, this particle here will feel an acceleration in this direction. It's a negatively charged particle, so it will be attracted. Okay, and if I write down its acceleration, I can just write mass into acceleration is equal to this, which gives me very simple and beautiful equation. A is equal to k q1 q2 by mr cube into x. K q1 q2 by mr cube into x. I hope everybody is following. I hope everybody is following. Now here, if you see that this distance x is in a positive direction, if you see this distance x is in positive direction and the acceleration a is in negative direction. Okay, so actually if I write things in vector form, guys, if I write things in vector form, I can actually write acceleration A is equal to negative k q1 q2 by mr cube into x. Okay, this negative sign just tells me that acceleration is opposite to the position. Now, if I compare this with standard SHM equation, I get the value of omega square. If I compare it with standard SHM equation, I get the value of omega square as k q1 q2 divided by mr cube. Okay, which gives me omega is equal to under root of that, which gives me time period as 2 pi by omega, which will become under root of, sorry, which will be 2 pi under root of mr cube divided by k q1 q2. Okay, now we just have to substitute. The final step in this question is just to substitute the values. Okay, so if I substitute the values, guys, what will I get? What will I get? What will I get? I will get T is equal to 2 pi under root. Now mass was given as 0.9 grams. So it will be 0.9 into 10 power minus 3, 0.9 grams. Into radius was given as 1 meter, so 1 cube. Divided by 9 into 10 power 9, that is k, into 1 into 10 power minus 5, which is q1, and q2 I forgot. How much is q2? 1 into 10 power minus 6. 1 into 10 power minus 6. Okay, this will just give you, if you check, t is equal to 2 pi by 10 seconds. This will just give you t is equal to 2 pi by 10 seconds. If you check, minus 11 and 13 minus 11 minus 2. Yeah. Okay, this will be 2 pi by 10 seconds. So if you check the correct answer, or they haven't given, so I will just say t is equal to 2 pi by 10 seconds. Okay, that will be the correct answer. I hope everybody understood, guys. If you understood, please give me a thumbs up. If you understood, please give me a thumbs up. Mahinder, Sri Lokesha. Oh, hi Lokesha. Hi everybody. Hi everybody. Okay, I hope everybody understood. Okay. All right. Now, guys, let's talk for 1 minute about JEE Vedantu's JEE Advanced crash course. If you want to prepare for JEE Advanced and you need a crash course, Vedantu is just a place for you. You just need to go to vdnt.in/JEECCE and use my coupon code to get the JEE Advanced crash course at 1999 only. Okay. If you do that, you get to study from the best faculties of India at very minimal price. Okay. So that's it. Let's go to the next question. What is the next question, guys? If I have this situation, I have two light springs. I have two light springs, K1 and K2, light as in massless. Okay, and K1 and K2 values are also given to me. Okay, this is 1.8 and 3.2, and in between I have a mass 200 grams, and this mass is going like this mass is oscillating between the two. Okay, so it will go first, then compress this spring, then come back, and then it will go in this direction, then compress this spring, and then come back, and it will go start its cycle all over. Okay, so this is how this particle is oscillating. This is how this particle is oscillating. You have to find its a time period. Okay, you have to find its a time period of oscillation. Okay, now guys, if you find out its time period of oscillation, what you have to remember is that in between these two springs, when the particle is going to move, okay, it is moving with a speed of 120 centimeters per second. Basically, it is moving with constant velocity. Why am I saying it's moving with constant velocity? Constant, not velocity, but constant speed. Okay, I can say call it constant speed at least. Okay, it's in this direction or this direction, doesn't matter. It will always move with constant speed, and from here to here it will be a half cycle of SHM, a half cycle of SHM, and from here to here it will be a half cycle of SHM. Okay, now in this case, if you have to calculate this time period, if you know all of this, things become very easy. You can directly calculate. What you will say is that in this case, sir, the total time period will be equal to half of 2 pi under root m by k1, the first spring, plus in this case, let's say this distance is equal to uh, th- this distance is equal to 60 centimeter, so the value will be 2 times 60 by v. The time taken will be equal to distance upon velocity plus half times 2 pi under root m by k2. Now, why did I multiply it 2 times? Because it will travel with this constant velocity 2 times in one cycle. It will travel at constant velocity 2 times in this one cycle. Okay, so I will just do it 2 times. And let's just substitute all these values, guys. So t will be equal to half into 2 pi into under root of Mass M is given as 200 grams and K1 is given as 1.8. So I can just write it as 0.2 upon 1.8 plus 2 times 60 by 120 plus half times 2 pi times 0.2 divided by 3.6, not 3.6, 3.2. Okay, if you substitute all the values, guys, if you substitute all the values, you will easily get the correct answer. If you substitute all the values, oh, 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 substitute all the values, you will easily get the correct answer. I hope everybody understood. Okay, so if you substitute all the correct values, you will get P is equal to, this will become pi by 3 plus 1 plus pi by 4. Okay, so this will be 1 plus 7 pi by 12 seconds. 1 plus 7 by 7 pi by 12 seconds. That will be the correct time period. I hope everybody understood, guys. I really hope everybody understood this question. Okay, really hope that will be the time period. They haven't given options, so I'm guessing my answer is correct. I don't know. Okay, but guys, before you go, that is it for today's class. But before you go, I want to give you a homework question. Okay, this is the homework question. Please try to find the answer to this and then write the answer in the comment section. Write the answer in the comment section. Okay, I hope everybody understood, guys. I will see you guys tomorrow once again with a short revision session. Okay, and I will try to upload as many questions as I can, short revision session for this. All right. Okay, guys. So have a nice day, everybody. Bye bye. It's always nice to teach you guys. Surinder Singh is always here. I love Surinder Singh. Okay, Princey is also here. Hi, everybody. Okay. Bye 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 bye.